Hey there. In this video, we are building a smart password protected door lock system. And guess what? It's simple, secure, and super fun to make. We will use an ESP32 A keyboard for entering the password, a servo motor to lock and unlock the door, and an LCD screen to display the status. So let's get started. Let's take a look at the code algorithm. I will walk you through step by step so you can understand every part of it. The first thing is to initialize the libraries. So let's see that. There are 4 libraries which we will use. First one is the ESP32 Servo.h. This is used to control the servo motor. It allows us to move the motor to a specific angle. Liquid crystal used to drive the LCD via I2C communication, making it easier to display text. After that, the third library is the keypad. This library simplifies reading input from the keypad. Then finally, we have the password. This library helps us manage password functionality securely. Now here we have defined the pins we are using for the servo motor. This servo motor is connected to the GPIO pin 12 on the ESP32. We initialize the LCD screen. We are using a 16:2 LCD with I2C, which means it only needs 2 wires for communication. 0x27, this is the I2C address of the LCD screen. I2C devices typically have an address to communicate with. 16:2, this defines that we are using an 16:2 LCD, 16 columns and 2 rows. In the keypad setup, the rows and the calls, this represent the size of the keypad, which is 4x4 matrix. Key map, this 2D array represent the layout of the keys on the keypad. Row pin and call pin, this array represent the GPIO pins of the ESP32 to which the rows and column of the keypad are connected. Row 1 is connected to 23 pin on GPIO. Row 2 is connected to GPIO pin 19 and so on. So this was the connection to the keypad. Now let's move to the global variables. Is door locked a Boolean variable that tracks whether the door is locked or unlocked? It starts as true, meaning the door is locked initially. Password, we use the password library to create an instance of the password with the initial password being 1234. Max password length, the maximum number of characters allowed for the password input. Current password length, this keeps track of the number of characters currently entered in the password. Keypad instance, this line initializes the keypad object, passing the key map, row pins and call pins and the dimension of the keypad, rows and calls. Now in the setup function, we initialize serial monitor, servo.attach servo pin. This attaches the servo motor to pin 12. Then servo.write 10. This set the servo to 10 degree, which we assume is the lock position for the door. LCD.init function initialize the LCD screen. Backlight function turns on the backlight of the LCD. Set cursor 0,0 sets the cursor to the top left corner of the LCD screen. LCD.print will display a welcome message on the LCD. Then we have a 2-second display delay. LCD.clear function clears the LCD to prepare for the further information to be shown. In the main loop function, we have LCD.setCursor 3,0. This moves the cursor to position 3,0 to display the lock status. Is door locked? LCD.print. This ternary operator check if the door is locked. If true, it displays door locked. Otherwise, it displays door open. After that, we will see how we can handle keypad input in the code. Keypad.getKey, this reads the key that we pressed on the keypad. Serial.printKey, this print the key that was pressed to the serial monitor for debugging. Then we have delay of 100, a small delay to avoid bouncing and ensure the key press is registered correctly. If the hash key is pressed, it calls the reset password function, which clears the password input. Toggling lock pressing star. If star key is pressed, we first check if the password entered matches the stored password using password.evaluate function. Let's say if password is correct, it toggles the lock state. If the password is incorrect, it displays wrong password and try again on the LCD. This part handles the number key. When a key is pressed, it appends the character to the password and update the LCD with an asterisk or star mark the entered characters. Let's move to the locking and unlocking function. Door locked. This function is called when the door is locked. It moves the servo to 10 degree and show a message locked on the LCD. Door open function is called when the door is unlocked. It moves the servo to 180 degree and show a message unlocked on the LCD. Resetting the password. Password.reset function reset the password input. Correct password length equal to 0. This reset the password length tracker. LCD.clear clears the LCD to prepare for the next input. Now we are displaying the message here. This function is used to display message on the LCD. First it will clear the screen, then it will print the first line of the message on the first row and second line on the second row. After displaying the message for 3 seconds, it clears the display. So that's all with the coding part. Now let's see how we can simulate this. Click on this start simulation button. After that, you can see door lock system is printed, and after that it will show door is locked on the LCD screen. Now let's enter our password, which is 1234. 1234. You will see the password is shown in the star mark, and then after that, once you enter 1234, you just click on the star or the asterisk mark. As you can see, the servo motor position got changed to 180 degree, and on the LCD it is showing door open. If you again press the star or the asterisk mark, it will move the servo to the lock position and it will say door is locked. This is how you can work on this smart password system project. I hope you like this project. If you have any doubt, just reach me out. Thank you.